So in this final slide deck for this unit, I'm going to talk about some of the advanced options in DNS for Microsoft Windows. And the first one is the DNS socket pool, which basically is a pool of port numbers that can be used for DNS queries. In other words, it basically protects against the DNS cache poisoning by randomizing the source port when performing a DNS query. So when you perform a query, it has to listen on a port for the response. It can randomize that port. That way, somebody can't try to sneak in an update. Which would cause DNS cache poisoning, right? You would allow somebody to make an update when they shouldn't be making updates because the real person trying to make the update doesn't actually end up getting made. So I know that sounds confusing, but the DNS socket pool can help prevent that. So it causes the server to return incorrect IP addresses if you don't have this enabled and somebody is able to pull off this type of attack. So to configure this, it's enabled by default in 2008 R2 and later. You can configure the socket pool size and you can exclude port numbers. So you might need to exclude port ranges if you are using other services on your server. So for example, if you had a service listening on port 104, by default, the DNS server might listen on 104 when it does this randomization, and there could be a conflict. So you might want to control what port numbers are used for this. So you would use the command that you see here in the slide in order to do that. DNS cache locking allows you to control whether data in a DNS cache can be overwritten. So what could happen is an attacker might be able to do a DNS lookup, see that you have something cached, and then do an update to get that changed. So you obviously don't want that to happen. So you can enable DNS cache locking, which prevents somebody from being able to do an update on that record with DNS. Basically, the way it works is whenever you have DNS caching, there's a TTL value for DNS cache. TTL is the time to live. That means how long do you keep the information that you've received. And if you set the cache locking value to 100, that basically means that the data, it can never be overwritten because it's going to be locked for 100% of the time to live. But you could set that at a lower value, like 75%, and then it would allow the record to be updated once the time to live reaches 75%. That way, a device might need to update that record before it expires. So that's how cache locking basically works. Recursion I sort of talked about in the previous slide deck, but recursion is basically a recursive query which might involve a forwarder in which the DNS server sends a recursive query to the forwarder. By default, recursion is enabled in Windows DNS servers. It sort of needs to be because if you want to run a DNS server that people can use to not only do name lookup, lookup records in their own network, but also for, like CNN.com or something out on the internet, you have to do recursion for that to work. You have to do a recursive query out to the internet to look up that information. So you could configure the forwarders as to who they can do recursion with or who they can forward that query. So typically, if you have a network, if you have an ISP for your network, they may be doing your downstream DNS, so you would set up the forwarder for them or maybe to a group of servers that they have that they give you. You can disable recursion entirely, which would not allow you to use forwarders at all, so it wouldn't be able to do lookups out on the internet. And so you can see here are some of those advanced options for recursion. NETMASK ordering is basically when you do a DNS query, there can be many results to a DNS query, right? So it's not, sometimes you don't just have one IP address. There might be, with an A record query, for example, that might give you back 22 different IP addresses. Take, for example, Google. If you try to do an NS lookup on Google right now, as I'm doing this, just type NS lookup, hit enter, and then type google.com in a Windows command prompt, you're probably going to see, probably 10 or 12 different IP addresses, and sometimes they're just kind of randomized as to which ones you get. But what you could do with NETMASK ordering is, if you have multiple IP addresses for the same domain name, it can look at the NETMASK that your query originated from and give you results that are most relevant to you based on where you are in the network. So you can configure that in DNS so that if somebody is on network A and does a query, instead of getting back an IP address on network B, then network C, then network A, it can order them so that the closest match is at the top of the list. That way you're because by default, most DNS clients are just going to use whatever comes back first in that list, and if that fails, they'll try the second one and so forth. So it's best if the one that you want to try first is at the top of the list. So that's what NetMask ordering does for us. The global name zone is how you can add a single label name. So normally we have to use FQDNs with DNS. In older versions of Active Directory, by default, our internal network's DNS was global names. It was essentially just a single name. And of course, today we use FQDNs because it meshes much better with the way the rest of the internet works. But that means you have to remember the full FQDN for something. So, it could be something.something.something.something.com, right? It could be many different levels of in the FQDN. So, for example, msdn.microsoft.com, right? That's an FQDN, and it has 3 parts. Sometimes some of those parts might be kind of confusing. For example, if you do an IP config on your own computer and you're at home right now, and you use Comcast or Verizon or one of those ISPs, you'll probably see a rather long, confusing FQDN for your computer's name. So if you use a global name, then you can basically use one word and have just one word resolved to an IP address. So for example, I might create a global name called file server. And that way, if anybody ever needs to get to the file server, instead of having to put in WFSF server1.mycompanysub.company.com to get to the file server, they can just type file server, and that's it. And they can access that resource. And I might do that with all the common things like time clock or billing or, something, or help desk or something like that. So that's what a global name basically is. You can also enable event logging and use debug logging. So when DNS is installed, you get a new event log in the record, and you have informational error and warning events that are generated by the DNS server. So you can view those events in the event viewer, just like most other services. So some common events you might see are zone serial number changes, zone transfer requests, DNS server startup and shutdown events. Debug logging can be enabled in the server property box, which will give you additional information. So if you're having a problem with DNS, you would want to go in and enable debug logging for DNS. So you can see here there's a whole bunch of options that you can turn on. I would caution against leaving this on all the time because it will bloat the log file, but it certainly gives you a lot of information, and this is an example of what that debug log looks like. So this can help you troubleshoot issues with DNS or with the DNS server in Windows. And then you can analyze DNS zone level statistics. So you get a couple different reports. You can show statistics for zone queries, zone transfers, and zone updates. And it can give you a good idea of how the DNS server is being used. You can delegate administration to other users. By default, anyone in the domain admins or enterprise admin group has full access to manage DNS. But in some cases, you might want to delegate authority to somebody without having to make them a domain admin or an enterprise admin. So with DNS, you could do that. You basically put that user in the DNS admins group, and they'll be able to administer DNS without having to be a domain administrator. And that concludes this unit, where we've talked about both DHCP and DNS and a little bit about how they're interrelated. And in the next unit, we're going to start talking about IPAM and some additional, which is IP address management. So it's going to kind of be the next step with DHCP. We're going to also talk about some rights management, some additional rights management capabilities with Active Directory.